Okay, I think I'm going to space the learning out. I think that's the strat. I just have to do it right. So we do like, I don't know, maybe I'm trying to, I don't know how much of the, I mean, I think that testing is pretty important. I'll keep doing the hour and a half each time, and I'll just do the test as an hour and 45 straight, because the time goes faster when I'm making stuff. But when I'm learning, I'm going to split it. So 45 minutes, 45 minutes. That way, there's a little bit of retention involved the second time around, and my brain has maybe had time to process in the background some of the shit I learned during the first session. So, okay, we learned about function or template type parameters, where we, define the different type names that we're going to be using. That way, at compile time, once we have called the template with arguments, the template can then instantiate functions, and basically, here's the template, here's a piece of paper, and we can sketch out this function, pass another thing, sketch out this function, sketch out this function, and it's one template, and we're calling it, and each thing we put in, it spits out a way of handling that proper information. Pass it integers. Okay, it makes an integer function. It says, hey, there's at least one call to this function, or to this template with an integer. Therefore, we need to make the integer version. Oh, there's also a call for a standard string. Doesn't matter if there's one call or 400 calls. We still need to make the standard string definition function, instantiation. Function templates converted this guy into this. Okay, so instead of max, we do max t. Does that mean I'm not understanding the benefit of saying, or of, maybe it would be ambiguous. I'm trying to see why, or trying to think of if there are any reasons right now where we would say max or a function name with parentheses and a template with angled brackets and a template type parameter. Is the T to differentiate it from max angled brackets with nothing in the middle? Does that mean something else? Or maybe you put T in the middle because, yeah, I mean, it seems like it might mean something else, at least in VBA code, in Word. In Word, the angled brackets together actually mean is not equal to instead of an exclamation point and an equal sign. So maybe the T is to add specificity and say, hey, this is a template as opposed to a, but I don't know what the as opposed to a is. So it seems like you would just do max parentheses and then max brackets, angled brackets. Okie doker. Yep, so we make a template clause beforehand. Coolio. And now we use them. Function templates are not functions. Yeah, it makes sense. We're basically saying, hey, compiler, here's this signal. Generate a function, instantiate a function that can handle this signal. Here's information. Generate a computer that can handle this information. And the compiler then does that. And then where I call main something something, that call is actually a valid call to, so it's more like, instead of me calling a function that doesn't exist, it's me calling the template and the compiler generating what is needed to make that call valid. Okay. They generate functions. Yep. What? Oh, this is totally different than what I expected. So it's the same shit. It's just that we have the template thing, just like static cast. So you might say that actual type. Hmm. Yeah, it seems like this follows static cast. So you could say that static cast is a template. And it's static cast, and then in parentheses, the type name of something. But it's different though. I think it has two type names, no? Because in the type, we're specifying this, but then we're passing it another type. And then somehow there's a conversion thing in there where it says, hey, here's this value, do some stuff to it, spit out this type instead. And that type is specified by the user, and the initial type is also specified by the user in the initial value that we are converting. Angled brackets. So for example, it seems like we're going to get to a part where the compiler can just intuit what's needed. So for example, we could say so what if we said, oh, well, yeah, because, so if we debug this, doesn't the local end up being, yeah, it is, yeah, it's 2.0. Okay. So yeah, so we can say, hey, these are these, so it's almost like, T is by default. Well, I mean, it seems like it would be. T is the same type as this shit in here. But I can actually change that type and it will convert these two. It's not that it says, hey, I'm passing it int, 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 and then I'm specifying a float, and then it simply returns the operation of these and then converts that to a float. Actually, it is I'm passing 1 and 2 as floats, and then we return whichever float is higher in this case. So really, this is like static cast. This is called static cast. We pass it one type, and I can return it. It's just that it's probably being implicitly converted here if I do it this way. For example, if we change this to be int 1.5, 2.2. Oh, okay, so we still get, yeah, it is still implicit. And I could static cast to an int. Boom. Fuck. Duh. So we would have to static cast this to an int and this to an int because there's no static cast going on here. There's nothing explicit. This is implicitly converting these guys into this guy. So it's saying, hey, this integer means that this, and this, these are all integer types. So we are initializing integer x with double 1.5. Nearing conversion. Same with int y with double 2.2. Okay. Which specifies the actual type that will be used. However, it can just intuit and say, hey, the arguments, boom, that's the type we're going to use. A default template parameter type, or type template parameter. Yeah, type is the template parameter is a type. In calls function max int, so it's creating this function of ints. So it's saying, hey, create int max int x int y, return the greater int, and pass it these two ints. It will determine the function definition for this not already exists. Okay, it's needed, and thus it will make one. This is good. Okay, just getting fuzzy from age. Felt like the shit was falling out. The foam. So I'll set my alarm. I'll go till 10, and then I'll just do an hour test at the end because I fucked the time up, and I don't think that I need as much. I think the testing is important, but I think it's easier to express knowledge and correct myself in it doesn't take as long a time to do that. So I want to get a bunch of information in my head as much as I can reasonably put in it, and then boom, lock it in. Okay. Compiler sees that and says, hey, is there a function called max that is taking two integers? What happens if we have a function that looks just like normal, except we call it using the template syntax. Okay, and I call it So this is cool. This is not cool. And it's because I'm not saying, Mr. Template, please make a function and use this integer as your guy. So what if we do this for multiple types? So we could do template, type name X, or type name T, type name Q. And then we call do thing. Can I pass it 2? What if I pass it? Yes, I can. Yes, I could say int float x, y. Or, well, I need to fucking put in the numbers, so we're gonna say 1, 3.3 f. Bop. Works. Sick. Doesn't do anything, but cool. I can just put any value there to reset IntelliSense for templates. Annoying, but okay. So when it sees this call with some template shit, and it's cool for subsequent calls, huh? Right, cool. You don't have to make it like your first call. So it's not like, oh, I call it once and then the compiler's cool and then the rest. It'll just swap them out for the right call. Creating a function with specific types from templates with their template types excuse me, is instantiation. Function template instantiation. Excuse me. Because it's a template for a function, it is a function template's instantiation. Implicit instantiation? A function of a template that was made by the template, generated by it, is called a specialization of the template, meaning that the template is good for all data types, but the specialization is good for one. It's a specialization of the template. Or you could just say it's an instance of a function that was generated from that template. Template from which is called the primary template, okay? I'm not sure why it isn't just called the template. I think the reason is because apparently there are template. What was it called? It was like, it's not template parameter, but the parameters, the template parameters were templates somehow. Template? That's a weird word. Excuse me. Specialization is to refer to explicit where we can explicitly define a specialization instead of having it be made from the primary template. Meaning, what? I mean, is that different than simply making the template? And then what happens if I have a template for intent, but then I already, or a template, and then I define the intent, and then I call the function with intent? Well, if I removed the intent one, the literal int including one, and called it, it would work with the template. But what happens when we have both? Does it override and explicitly do it? I'm not sure if that's that, but maybe there are reasons to do it. Seems like a waste of effort, but maybe the results need to be different, like we saw before, where we had we were calling one function and then we used a template to catch all the other calls to the function. And if we called the explicit function, we were cool. We call the integer version, we're good. But then if we call it with anything besides an integer, then the template kicks in, and in that case, we deleted it. So we couldn't call it, something like that. That way we can handle all possible calls that we don't want. So we could say, hey, first there's a template, and there's a void do thing that uses it, tx. Okay, but then there's another void do thing that has int x. Okay, and what if we call do thing 1? It's okay. Why? Because it's calling straight up int x instead of calling the template version. If I instead said true, there are 2 overloads. When I did an int earlier, there was only 1 overload, and it seems like this guy is the other overload. But when I do this way, this guy generates a Boolean, so there are 2. So the first call didn't generate another, so we called this one and there's 1 overload. But now since we actually called this guy and it generated 1, not only is this guy an overload, but then there's the actual Boolean one that's an overload. Or it's that the template one is the overload, and the Boolean one is not, even though that's technically the current overload that we called. Get some music to wake me up. Cool and cool. Seemed like I just did explicit specialization because it wasn't instantiated from the primary template. It was just made. Again, I don't know why we're... Well, I guess it's primary template because we could use a template to generate other templates, maybe? Maybe there are different types of templates. Like, hey, this template is good to make these types. This one is good for these types. And in this case, it does this logic. In this case, it does this logic. So we have a primary template that generates secondary templates that instantiate their function templates. Compiler clones the primary template. Oh, I'm paying pretty good attention even with music. This is good. Makes sense, yeah. Copies the template and replaces the type with the one that we passed as an argument. Yes, well, I guess we didn't pass it as an argument. We actually explicitly set it in angled brackets. We call it saying, hey, take int and swippy swappy. Substitute them in. Just ignore this for now. Oh, specialization that is created is something like that. Max int. Oh, does this answer any of the questions I was asking about templates before? Like a standard numeric limits, and then there's a template part, and there's a function part, and that means that this standard numeric limit is so numeric limits has a template clause. I need to stop holding my eyes shut because when I think with my eyes shut, it makes me tired. Ah, fuck. All right, now I gotta do push-ups to wake up. All right, let's do some jumping jacks. Not always push-ups. So, all right, well, hold on. Let me fucking get my shit situated or something. Get banned. We good? All right, we'll do this. I don't know. I don't want to do that. All right, so we have. Is that shit loud? It's probably pretty bad. All right, well, who knows? I'm just gonna jump. Fuck it. So we've got standard numeric limits, and we pass it the size of something we're trying to find the limit of, and then well, actually in that case it doesn't have a. So that's a class template. Holy shit, it is. Because it's a class that has a member function, and that member function does shit depending on the type that it has. What's another case? There's one with the return type. No, it's just static cast. So static cast could be one. Static cast could just be a regular ass little function. It just has shit going on inside. So static cast is a primary template, and it has specific things that it would, well, maybe it's more than that. It could be an object that has just the operator parentheses as the caller, just like for a Mersenne twister or a uniform int distribution. So in static cast, we're passing it the type that we want shit to be converted to, and we're passing it arguments, the actual thing we want to be converted, the value of some type that we want to become another type. So, but if it's a simple primary template, then the function instantiations, the specializations it generates, the function instances, shouldn't differ. So I'm not sure how it would be able to, unless there's one thing that it calls, like a convert value function. Maybe that's what it is. But then wouldn't we just call that? I don't know, maybe there's some cleanup it does. So if I assume that we pass it an argument, pass it the type we want it to become, which the template type parameter is substituted for, so from t to an int, because I'm converting a float to an int explicitly, it calls its little convert value thing, and it passes it the initial type and then the final type, so float to int. That function does some shit, but then it does some cleanup. That way, anytime I call it with different with a different template, what do we call it? I guess with a different template type argument. Like when I pass it with a different one, I pass it with an int versus a float, it generates an instance for the float. Yeah, and I'm only passing it that one. I'm not passing it both. So I guess it passes the value to that conversion function, which already has like conditionals and shit, and it'll say, hey, if it's starting at this is how you convert this to an int. If it's this is how you convert a float to an int. This is how you convert these different things. So if we do, I think numeric limits has its own scope. Now, how does that work? Now, there's a question. Because if we're saying that when we make, if I make template, it's hard to type fast. Type name, isn't that what it's called? Yeah. Okay, and then we say, excuse me. Okay, and we say that if I pass it an int, then it generates void do thing int x. What would it actually say here? Oh, this is an explicit template one. Instead of just saying this as an overload, we can explicitly do it. What was it complaining here? Not allowed because who knows, maybe I have to do something that allows it. So if we did, well, we could just say wait. Well, yeah, void ignore line. Well, we don't even need to do that really. We could just say, well, yeah. We also need input and output. Well, really, we just need the input. And we can ignore, or we could say clear input buffer, either way. Ignore line doesn't work. Like that. And then we'll say, well, I mean, it's really clearing the input buffer to the next value. So we could say something like that, whatever. We'll say ignore line. Sure. And what we're doing is we're going to standard numeric limits, but so it is a class template. But the interesting thing is that the class has max, but that's not how we get a member function. That's with the dot operator. Like this. So we pass it a standard stream size. And then I pass it whatever the fuck, or then we do max or something else. Like this. Thing here, this is a class. And there's some sort of template shit going on. But this isn't a member function. This is something inside of it. So somehow I think we're getting into like object-oriented programming. Which is 3 chapters away. Well, really 2 if we're saying 12 and 13. Because it's 14. The function specialization looks... Oh, shit. Is that how this works? Oh, shit. Does this just mean, hey, yo, continue this guy? What if we did it the other way? Womp. No specialization because the template doesn't exist yet, bucko. What if we had a regular ass definition before it too? Oh, okay, so it's still fine. So, wait, really? Oh, yeah, because it's looking at the identifier and it's saying, hey, there's already a template for this identifier. You're cool to make an overload that is an explicit specialization. Because it has to be the same identifier, so it's fine. What would the error say if we just did another... Really nothing? Interesting. I'm surprised there's no conflict there. It seems like the template's maybe included in the signature. But didn't we say, oh, we said default arguments aren't. So maybe templates are. I mean, I guess they have to be for the compiler to know if it's a template or just a regular function. How long have we go? The fuck? Almost 40 minutes already? That was fast. But the compiler actually compiles all after all instantiations are done. And that's exactly what I just wrote. Makes sense. We have a template, and then we're continuing an existing template for this identifier, which is max. That's why it doesn't complain. And then we say, hey, we're specializing it with this int. And then there are two parameters. Parameters. And then we call that guy specifically, and we're saying, yo, that's the one, bro. And if this guy didn't already exist, if this specialization wasn't already there, then it would do whatever. But we could have an explicit specialization because it does some extra shit. And this is the case, even though we have a declaration, we don't have a definition. And the reason is because when we pass it an int, we already have a specialization for int. What the fuck? Who middle clicked? I didn't. God damn, we have a lot of shit to cover here. God damn. Yeah, so we could say stop, close my eyes. I mean, I don't want to just have... Whatever, I'll just have placeholder functions, it's fine. So we could have template, type name T, and then we could have void do thing, and then it takes a TX, and then we have just a declaration. There's no actual definition going on here. And it's fine. It's just that there's no definition. Yeah, but then we can have template continue. And what is this saying? This needs the rest of the puzzle. Oh, wait. Really? Bro, what are you tripping on? Oh wait, this isn't the for I fucked up the for declaration. Yeah. So in this, well, I mean, in this case, we're not touching X. We're saying, hey, there's a primary template here. And I mean, really, we would want some shit in the primary template so that it generates a fucking real body. Because if we explicitly do it, well, if we're doing a bunch of different explicit instantiations or specializations, we may as well just make a bunch of separate fucking functions, dude. But maybe you want to have your primary template generate stuff for these types, but then for these types, you have a specialization or two ready for them. And for you to continue it, oh shit, hold on, there's multiple here. So we have, whoops, yeah, I totally missed that. All right, yeah, so that's how we continue a template, or that's, I guess that's like a specialization guy. Oh, and that answers the question earlier. We don't say max boom boom. We say max boom T boom. So it's angled with a T with a T in the middle. To say, hey, that's the primary guy. It's the primary template. Compared to the template specializations. Oh yeah, fuck, I forgot I need to do dishes. Or well, I need to just run them. This template exists. And there's this generated function. So there's an explicit specialization of that primary template for an int. And then I can explicitly call that one if it has different shit than the other specializations that the primary would generate. It's only instantiated the first time a function call is made. So further ones just go to that existing one. Yeah, that makes sense. That scared me. Alright. Oh, alright. You know what time it is? Time for the self-testo, yo. You're back.